Hello students, Jai Hind, Vande Mataram. Once again welcome back to the class of Ravi sir, the easiest and finest way to learn the concepts of mathematics from standard 9 to 12th. Students, in our today video lesson of standard 12th maths chapter 2, we will practice the miscellaneous exercise. Students, before starting today video lesson, if you are new to this channel, just subscribe this channel and don't forget to hit the bell icon. Okay students, let's start over here. The first question: find the value of cos inverse cos 13 pi by 6, right? So let us see the solution. Cos inverse cos 13 pi by 6 is equal to cos inverse. Now cos 13 pi by 6 can be written as 2 pi plus pi by 6, right students? So here we are considering 2 pi revolution, so 2 pi again pi by 6, so here we will get pi by 6 which will be lies between 0 to pi, right students? So cos inverse cos 2 pi by 6 can be written as pi by 6, so cos inverse cos pi by 6, so cos will be cancelled, so we are getting pi by 6, right students? Now moving to the next question. Tan inverse tan 7 pi by 6. So students, we will solve this question similar to the previous one. Tan inverse, now tan 7 pi by 6 is equal to tan inverse tan pi by 6, right students? 7 pi by can be splitted as pi plus pi by 6, so again pi by 6 lies between minus pi by 2 to pi by 2, right student? So tan inverse tan 7 pi by 6 is equal to tan inverse tan pi by 6, so 10 again will be cancelled out, so we are getting pi by 6. Okay, moving to the next question. The next question is question number 3. 2 sine inverse 3 by 5 is equal to tan inverse 24 by 7, right? So let us write the LHS. LHS is what? 2 sine inverse 5 by 3 by 5, so 2 sine inverse 3 by 5, we can write what? Sine inverse 2 into 3 by 5 1 minus 3 by 5 whole square by applying the formula of 2 sin x. So we know that student 2 sine inverse x is equal to sine inverse 2 into x in the square root 1 minus x square. We have applied this formula to the above step. So sine inverse, here we are getting 2 into 3 by 5. Now simplifying the square root terms, so we are getting 4 by 5. So sine inverse 24 by 25, right? Similarly, we can write these things in the form of tan. So sine can be converted into tan, so sine inverse x is equal to tan inverse x upon 1 minus x square. So in the form of this term, in place of x we will write what? 24 by 25. So we are getting tan inverse 24 by 25 divided by square root of 1 minus 24 by 25 whole square, because we know that sine inverse x is equal to tan inverse x upon 1 minus square root of 1 minus x square. So now students, we will simplify this term. So here we are getting 24 divided by 25. Now simplifying the denominator term, we are getting 576 by 625. Again the next term will be tan inverse 24 by 25. here will be, by simplifying the denominator and taking the reciprocal of it, we are getting 25 by 7. 25 will be cancelled out, students. So we are getting 24 by 7, right? This is what RHS. Hence we proved LHS is equal to RHS. Okay. Now moving to the next question. Cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65, right? Here we will prove the LHS is equal to RHS. First of all, writing LHS, cos inverse 4 by 5 plus cos inverse 12 by 13, right, students? So cos inverse 4 by, applying the formula of cos inverse x plus cos inverse y, so here we are getting cos inverse 4 by 5 into 13 by 12 minus square root of 1 minus 4 by 5 whole square into square root of 1 minus 12 by 13 whole square. Because we know that, students, cos inverse x plus cos inverse y is equal to cos inverse x into y minus square root 1 minus x square into 1 minus y square. In the above step we have applied this formula, right, student? Now just we have to simplify the terms which are in the braces. So we are multiplying over here, so we are getting 48 by 65 minus simplifying the first term in the root and second term in the root, we are getting 3 by 5 into 5 by 13. So cos inverse 48 by 65 minus 3 by 13, right? 5 will be cancelled out. Now cos inverse is equal to what, student? By simplifying the terms we are getting 33 by 65, which is equal to RHS, because in the RHS we have to prove that cos inverse 33. So LHS is equal to. Now students, moving to the next question, question number 9. Tan inverse root x is equal to 1 by 2 cos inverse 1 minus x upon 1 plus x, where x belongs to 0 to 1, right? So first of all, writing RHS term, we will get LHS 1 by 2 cos inverse 1 minus x divided by 1 plus x. Okay, student? So let us consider x is equal to tan square theta. Then root x will be what? Tan theta, right, student? So substituting the value over here, 1 by 2 cos inverse, here we are getting 1 minus tan square theta, right, divided by 1 plus tan square theta. Okay, so we know that 1 minus tan square theta divided by 1 plus tan square theta is tan 2 theta. So cos inverse cos 2 theta. So cos will be cancelled over here. So we are getting 1 by 2 theta, 2 cancel, is equal to theta. So from here root x is equal to tan theta, we can find out what? Theta. So theta will be tan inverse x, which is equal to RHS, because theta is equal to tan inverse x, right, students? So in this way you can prove this question by considering the formula of cos 2 theta. Now the next question, 9 pi by 8 is equal to minus 9 by 4 sin inverse 1 by 3 is equal to 9 by 4 sin inverse 2 upon root 2 into root 2 by 3, right? So again considering LHS term, 9 pi by 8 minus 9 pi by 4 sin inverse 1 by 3. So 9 by 4 will be common, so we are getting pi by 2 sin inverse 1 by 3, right? So 9 by 4, so this term can be written as cos inverse 1 by 3, because students we know that sin inverse x plus cos inverse x is equal to pi by 2. So the value of pi minus sin inverse x will be what? Cos inverse x. In place of x here we have wrote 1 by 3. So we will turn this cos into sin. So 9 by 4 sin inverse 2 root 2 by 3. Right students, because we have applied the formula cos inverse x is equal to sin inverse. Now students, moving to the next question, number 16. Sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. Then x is equal to dash. It means students, here we have to find out the value of x, right? So let us see the solution. Here it is given that sin inverse 1 minus x is minus 2 sin inverse x is equal to pi by 2. Okay, so let us consider student x is equal to sin theta, right? Now putting the value of x, so we are getting what? Sin inverse 1 minus sin theta minus 2 sin inverse, right? 2 sin inverse x in place of x sin theta is equal to pi by 2, right? So students, just writing the value, same value over here, right? What we will write? Sin inverse 1 minus sin theta, right? We will write the same value, sin inverse 1 minus sin theta minus 2 sin inverse sin will be cancelled, so we are getting 2 theta by pi by 2. Now students, minus 2 theta will be equal to pi by 2 minus sin inverse 1 minus sin theta. Okay, so minus 2 theta is equal to, it will be equal to cos inverse 1 minus sin theta, because students we know that sin inverse x plus cos inverse x is equal to pi by 2. So the value of sin inverse x will be what? Pi by 2 minus cos inverse x. In place of x, here it is in 1 minus sin theta. So applying cos on the both sides, so cos minus 2 theta is equal to 1 minus sin theta, because cos inverse will be removed by cos. So cos 2 theta 1 minus sin theta. So cos 2 theta is equal to what? 1 minus 2 sin square theta, right? This is 1 minus sin theta. Okay students, so 2 sin square theta sin theta, because 1 cancel, so 2 sin square theta minus sin theta is equal to 0. Sin is common, so sin theta into 2 sin theta minus 1 is equal to 0. Here it is when sin theta will be 0, sin theta is equal to 0, and 2 sin theta minus 1 is equal to 0. So sin theta is equal to 0 over here, right? So we can write x is equal to 0 and 2x minus 1 is equal to 0. So x is equal to 1 by 2, right student? So x is equal to 1 by 2 does not satisfy the above equation. If we will put, we will not get pi by 2. So x will be what students? 0. This is the correct answer of